In this video, we are going to do a few more examples where we are going to find derivatives that require the use of the chain rule. So let's look at our first example. Let's find the derivative of f of x if f of x is equal to 3 times 4x plus 8 raised to the 9th. So our derivative of this. So we first need to identify what is the outside and inside function. And here, the inside function is the 4x plus 8. So the outside would be like a 3x to the 9th. So we're taking the derivative of that. So we would bring the 9 down, so you'd have 27. Stuff on the inside is going to stay the same, and you subtract 1 from the power. Now the stuff on the inside was 4x plus 8. And then we need to multiply by the derivative of the inside. Derivative of the inside is 4. That is our derivative. All right, let's look at our next problem. Next we have r of t is equal to cosine of t squared plus 3t. So our derivative, we need to again identify the outside and inside function. So our outside function is cosine. On the inside is the t squared plus 3t. And so we'll take the derivative of cosine, which is negative sine. The inside stays the same, and then we multiply by the derivative of the inside. Derivative of that inside is 2t plus 3. All right, let's keep rolling. Next we have g of x is 4 sine cubed x plus 2x. Now this one gets a little bit tricky because when we write sine cubed x, that means we have sine of x cubed plus 2x. So when we take our derivative here, do we have a composite function? Well, kind of, right? So this is a composite, this piece is composite, but this is not composite. So how do we deal with that? Well, because it's separated by a plus, we can just take the derivatives of these two pieces separately. And so for the sine, for 4 sine of x cubed, we have 12. We can bring the power of 3 down. The inside stays the same. Subtract 1 from the power. Multiply that by the derivative of the inside, which the derivative of sine is positive cosine. And then we have the derivative of the next piece. So the derivative of the 2x is 2. Great. All right, next up we have this function. So when we take our derivative here, actually we're going to need some space, so I'm going to write it down here. Why are we going to need space? This is r squared times tangent of 3r plus 17. Yeah, so what do I need space for? Well, we need space because we have r squared times this other thing. So when we go through, we're going to have a product rule that happens. In addition to the product rule, we will have that chain rule that's going on. So our product rule says we're going to take the derivative of the first. So the derivative of r squared is 2r. So derivative of the first times the second plus the first, the r squared, times the derivative of the second. Now, our second is the tangent of 3r plus 17. So we have a chain rule that's going to happen there. Our outside function is the tangent. Its derivative is secant squared. The inside stays the same. Times the derivative of the inside, which is 3. So lots happening there. We need to be really careful. We have a product rule and chain rule that's going on. All right, let's look at our next one. Next, we have 4 times the square root of 3x squared plus secant x plus 9x plus 3. So here, when we take our derivative, that square root is the same as a 1/2 power. So you can bring that 1/2 down. So you have 4 times 1/2, which is 2. The inside stays the same. We subtract 1 from the power, so that power was a 1/2. Now it's going to be a negative 1/2. Times the derivative of the inside. The inside is going to be 6x plus secant x tangent x. So all of that is just the derivative of this first piece. And then to that, plus the derivative of 9x, which is 9, plus the derivative of 3, which is 0. Excellent. Good. And finally, we have g of t is equal to 6 over 4t squared plus 2t plus 7. And as you look at this, you might say, oh, that's great. We can just use the quotient rule. We can fly through that. And I would say that is absolutely true. But let me show you one other way we could now think of this problem. So before we take our derivative, we could write it as 6 times 4t squared plus 2t plus 7 to the negative first power. And so then, when we take our derivative is negative 6. The inside stays the same, 4t squared plus 4t squared plus 2t plus 7. So we brought the negative 1 down, subtract 1 from the power, negative 2, times the derivative of the inside, which is 8t plus 2. So this is negative 6 times 8t plus 2 over 4t squared plus 2t plus 7 squared. That is our derivative, and we can get to that derivative using the chain rule. In our next video, we'll look at a couple more examples where we are going to use the chain rule. These will be a little bit trickier because they are going to require us to use the chain rule a couple times. All right, we will see you there.